Hello everyone. This is the continuation of the simulation of basic gates using Pspice software. In the last video, we had seen how to rig up the circuits, digital fundamental circuits, in order to simulate the behavior of basic gates. Now we'll see how to simulate this basic gates. As you can see, we have taken all the fundamental gates like AND, OR, NOT, NAND and NOR gates. We'll be simulating XOR and XNOR in another video. And we have applied two stimulus A and B, and we have taken all the outputs by using if out. Now, next thing what we need to do is I need to give the inputs for the circuit. That means I have taken two inputs. I need to make the transition of these, and for those transition I need to observe how the gates will work. In order to apply the transition, just double click on the input. As you can see over here, simulator editor window will open and you can see the two waves A and B. Now I can choose either frequency or duty cycle, or I can choose period or runtime. Period and on time. If I choose period and on time, I need to specify the period. I can specify it in milliseconds. If I if I choose the period as 4 milliseconds and the on time as 2 milliseconds, and if I click apply, you can see the waveform that is specified here with the label A will change. As you can see, the period I have taken it as 4 milliseconds. The waveform A is of length 4 milliseconds. In the bottom you can see this is 0 and this is 4 milliseconds. In this window, one cycle will appear and the on time is 2 milliseconds. This is 2 milliseconds on time. This is how I can apply stimulus. Now I need to apply another input B. Just double click on it, the same window will open. Now the clock attributor's name is B. I need to specify the period and the on time. For the previous one I have taken 4 milliseconds as the period. Now for this I'll take 2 milliseconds as period and on time as 1 millisecond. If I click apply, the waveform changes. As you can see over here, waveform A and B. Waveform A has a period of 4 milliseconds and an on time of 2 milliseconds, whereas the waveform B has a period of 2 milliseconds and an on time of 1 millisecond. This is clear with what we have drawn. Now, after applying the inputs, I need to do one more setting in order to simulate this. What that setting is, I need to set up analysis. This can be done by clicking this icon, or I can go for analysis. And then I can choose setup. A pop-up window will open. Here I need to select transients. Under transients, I need to give two inputs. What are the things is final time I need to mention, and the step size I need to mention. Final time in the sense how long you want the circuit to run. Since I have taken 4 milliseconds as the length of A input, I'll mention the final time as 6 milliseconds. That means I want the circuit to run till 6 milliseconds with an incremental steps of 1 millisecond each. This is what I need to specify in the transient analysis. Final time is 6 milliseconds and the step size is 1 milliseconds. OK, and then close. Now with these things we are ready to simulate the fundamental basic gates. After having done this, I just need to click on this simulate option. Okay, before that, Since I have provided the inputs and I have applied the outputs, there is no way to see the output. In order to visualize the output, I need to take the voltmeter or level marker. Here you can see, you can choose the voltmeter or the level marker as the cursor is indicated. Just click on it and place on each output. Now place level marker or voltage indicator on each of the outputs. Same thing I'll do for input also. I have applied the inputs. I have taken the voltage indicators. Now I'll simulate it. Let's see if it works. Yes, as you can see over here, the inputs that I have taken and the outputs that I have mentioned in the circuit is what all available. The first two are A and B are the inputs. Input A is having a time period of 4 milliseconds. This is 0 millisecond and this is your 4 millisecond. And in this one 4 millisecond, I should be having one cycle of the input A. As you can see, A is having a level 0 until this point, that means till 2 milliseconds, and then the input rises to level 1 to this point, that is 2 milliseconds. The cycle is of 4 milliseconds, the on time is 2 milliseconds. Similarly, the input B has the same thing. B has a time period of 2 milliseconds from this point to this point, and then on time of 1 millisecond. You can observe over here. This is what the inputs that we have seen. Now we can check the outputs. The first output is NOT, second output is AND out, third output is OR out, fourth output is NAND out, fifth output is NOR out. We'll see here. If I draw the inputs in terms of zeros and ones, this is 0, this is also 0. Let me clear it. Zero zero 0 1 1 0, and then finally 1 1. You can see the inputs A and B is having level 0 0 over here, and then A is having 0, B is having level 1 1, similarly 1 0, and then 1 1. If I look, the output of NOT gate is having input of A, and then the output has to be inverted version of A. Input A is having 0 till 2 milliseconds, whereas output of NOT gate is having level high till 2 milliseconds. This is what, and it is exactly inverted at each time interval. The AND gate output will be 1 only if both the inputs are 1. You can see in this location, here both inputs are at high level, because of which I'll be having NAND output of AND gate as 1. Similarly, you can see the OR gate output. OR gate output will be 0 if both the inputs are 0. Here in this level, in this time instant, both the inputs are 0.